Hello dear students of plus 1 medical, non-medical and respected teachers. Today I am going to discuss the topic work energy theorem and law of conservation of energy from the chapter of work, power and energy for plus 1 class. Now first of all, what does it mean by energy? The ability or capacity to do work is called energy. Means ਕੰਮ ਕਰਨ ਦੀ ਸਮਰੱਥਾ ਨੂੰ ਅਸੀਂ એનર્ਜੀ ਕਹਿੰਦੇ ਹਾਂ. Energy is of many types: mechanical energy, light energy, sound energy, magnetic energy, nuclear energy, chemical energy, so on. But in this chapter I am going to discuss only mechanical energy. So mechanical energy is of two types: kinetic energy and potential energy. Now what is kinetic energy? The energy possessed by a body due to its motion is called kinetic energy. Means kinetic energy comes into play when body is in motion. And to derive expression for kinetic energy of a body, suppose a body of mass m starts from rest, and suppose F is the force acting upon the body and it displaces the body through a displacement S having acceleration A, and let V is equal to velocity acquired by the body at the final position P. Then amount of work done during this motion by the force is given by W is equal to F into S. By Newton's second law of motion, F is equal to ma, so it will be ma into S. So using equation of motion, V square minus U square is equal to 2as. Initial velocity 0, so we have V square minus 0 is equal to 2as. So from here we have A is equal to V square upon 2s. Substitute this value of A in this equation, so we get W is equal to m V square upon 2s into S. S cancels, so work done comes out to be half mv square. This work done by the force is converted into kinetic energy of the body. Therefore kinetic energy of the body is given by half mass into velocity square. So it is the required expression for kinetic energy of the body. For example, running water will possess kinetic energy. Bullet fired from a gun will possess kinetic energy. Any moving body will possess kinetic energy. And kinetic energy is directly proportional to mass and directly proportional to square of the velocity of the body. So more is the velocity, more is the mass, more is the kinetic energy of the body. Then potential energy. The energy possessed by a body due to its position, configuration is called potential energy. Now suppose we have a body of mass m and we have to lift it from ground through height h. So force required to lift a body is equal to weight mg. F is equal to mg. Therefore work done in displacing the body from the ground through height h is given by W is equal to, instead of Fs we have Fh now, because h is the distance covered, height attained, or F is equal to mg, so mgh. So this work done is converted into potential energy of the body at height h. So potential energy of the body at height h is given by P.E is equal to, potential energy is equal to m into g into h. So basically this is the energy, potential energy gained by the body after attaining height h, or we can say it is expression for potential energy of the body. So it will depend upon height. More is the height, more is the potential energy. Then we come to work energy theorem. Now work energy theorem, it is clear from the name that it relates work with energy. Now it states that amount of work done upon a body is equal to change in its kinetic energy. We are going to prove amount of work done by a body upon a body is equal to change in its kinetic energy. So for that, suppose again body of mass m, suppose u the initial velocity of the body, v the final velocity of the body, f is the force acting, a the acceleration, s is the distance covered. Then work done is equal to F into S, or W is equal to ma into S. Again using v square minus u square 2as, a is equal to v square minus u square upon 2s, or W is equal to m into v square minus u square upon 2s into s, s cancels. So it is equal to half mv square minus half mu square. What is half mv square? This is final kinetic energy and this is initial kinetic energy. So therefore work done is equal to Fs equal to half mv square minus half mu square. So work done is equal to the change in kinetic energy of the body, final kinetic energy minus initial kinetic energy, and this is known as work energy theorem because it relates work done with energy. Then we come to law of conservation of energy. Basically this is work done is equal to change in kinetic energy, also signifies the conservation of energy. The work that is done by the force upon the body is being converted into its kinetic energy. So, law of conservation of energy. It states that energy can neither be created nor destroyed, but it can be changed from one form to into another form. This is known as law of conservation of energy. So, to prove it, there are so many examples. So first of all, we will prove total energy of freely falling body. To explain this law of conservation of energy, total energy of a freely falling body is always conserved. Now, suppose we have a body of mass m at height h. Suppose it is allowed to fall down freely under the effect of gravity. Then it follow this path, vertical downward path. A is the top position, B is the position of the body at any instant in between the ground and the top position, and C the ground level. Suppose h is the height, AC is equal to h. No, we have to prove, if we prove total energy at A, total energy at B and total energy at C is same, then law of conservation of energy is verified. For that, first of all, at point A, let us see, because it is free fall, initial velocity is 0. At A, potential energy will be mgh by definition, and kinetic energy will be 0 because body is allowed to fall freely. So initial velocity is 0 at the top. So therefore, total energy is equal to kinetic energy plus potential energy is equal to mgh. So at A, total energy is mgh, say this is number 4. Now at point B, suppose body comes down through a distance x and height of the body at that instant is h minus x from the ground. Since it is coming down with under the acceleration due to gravity and the effect of gravity, so let v1 is the velocity attained by the body at point B, at position B. Then potential energy at point B is given by mg into height. Height is h minus x. Kinetic energy half mv1 square. To find v1, we use equation v square minus u square equal to 2as. It comes out to v1 square minus 0 is equal to 2g x. X the distance covered. It is v1 square comes out to be 2gx. Such the value of v1 square in this equation we have kinetic energy equal to half m, 2gx, 2 cancels. So kinetic energy comes out to be mgx. It means kinetic energy at point B is mgx and potential energy at point is mgh minus x. So total energy at point B will be equal to sum of kinetic energy and potential energy. So potential energy mgh plus mgh minus mgx, open this bracket. So plus mgx cancels. So total energy at B is again mgh. Now at point C, so at point C there is no height, h is 0. It means potential energy is 0. Kinetic energy is half mv square. So let v the velocity attained by the body just striking the ground. So again using v square minus u square 2as. So we have v square minus 0 for journey AC. Initial velocity 0, final velocity v is equal to 2g distance covered h. So it will be V square is equal to 2gh. Substitute value of V square in this equation, so we have kinetic energy is equal to half m into 2gh. 2 cancels. Again kinetic energy comes to mgh. Total energy at C is equal to potential energy plus kinetic energy. So is 0 plus mgh. So total energy at C is equal to mgh. So from question 4, 5 and 6, we conclude that total energy at A, B and C of a freely falling body under the effect of gravity is always constant and it is equal to mgh. So it means, moreover, this one form of energy is being converted to another form. So potential energy mgh being converted into kinetic energy. When body falls down, kinetic energy increases, potential energy decreases. So when we take the body up, throw upwards, so then kinetic energy will decrease and potential energy will increase. So it means total energy of freely falling body is conserved, constant, and potential energy of the body is being converted into kinetic energy. This is nothing but law of conservation of energy. So it means total energy of a freely falling body is always conserved. So this is all about kinetic energy, potential energy, expression for kinetic energy half mv square, expression for potential energy mgh, and work energy theorem. So work done is equal to change in kinetic energy of body, law of conservation of energy. Energy can either be created or destroyed, but it can be changed from one form to another form. And energy of freely falling body is always constant. This we have proved. So if you have to give an example of potential energy, so water stored in the dam, Pakra dam you can say. So when water falls down, potential energy being converted into kinetic energy. So energy stored by body raised to a certain height is also potential energy. So potential energy is due to position of the body. Kinetic energy due to motion of the body. So this is all about potential energy and kinetic energy and conservation of energy. In the next video, I will discuss potential energy stored in a spring and some other topics. Till then, stay tuned. All the best. Be happy. Good luck. Sarvat Dapala.